Yep. Hello, everyone. I'm Chenglong, and today I'm going to introduce you our work on transforming programs between APIs with many mappings. And this is work done with my collaborators in Peking University and National Institute of Informatics. Okay, so our stories start with APIs. So as we all know, API is the interface for us to use other software components. And these APIs are important, like language APIs, like Python system libraries, hardware APIs, like physics, or web APIs, like Google. One particular exciting thing about this API is that it keeps evolving over time so that it will become better and better. And the API developers always aim at providing us with API with better performance, better security, easier programming model, and more. So as a software developer, when you see these new fancy APIs, your idea is to switch to the new API so that you can enjoy all the benefits provided by the API developer. Well, that may not be easy because API changes can be incompatible. So for example, this is old API and the old client program that use the API. They fit well and they work well. However, someday the old API changes to a new version of API. It simply does not match your old client program, although there's a lot of benefits. You just cannot use it. And all you need to do is to transform your old client program to a new client program so that it fit the interface and work again. But this may not be easy because when you want to do manual transformation, it's typically error-prone and time-consuming. And more importantly, it's very boring. And the programmer will doubt himself. Should I really transform to the new API? Well, the answer typically is no. And they are just using a shabby API for a long time. So our community is great. Our community provides transformation language to support this problem. So what transformation do is that API providers will use this transformation language to write some rules to specify the relationship between the old API and new API. So that whenever you have an old client program, you include it with that language system together with the rules provided to API developers so that transformation is done automatically. And then the client programmer will be happy because he don't need to go through the suffering process of manual adaptation. Unfortunately, these languages are still kind of limited in solving this problem. The thing is that for general purpose transformation languages like Stratigo, it's pretty hard to write because you need to write all the context information like where your rule is going to apply and how the transformation happen. And there are also some domestic language for API transformation just for this task, but the expressiveness is pretty limited because they're only able to capture one-to-many mapping relations. Well, what is one-to-many mapping relations, and why are the other kinds of relations hard to capture? Let's just see a definition here. So by one-to-many mapping relations, it means that one invocation to an old API method is mapped to a sequence of method invocation to the new API. So I'm taking Java as an example here because this is what we do. So this is an example of using a swing and SWT API in Java. They are both GUI APIs, like programming your fancy GUIs. The first API is to set up alignment for button in swing. It's just called button.setAlignmentX. And the new API is very similar. It's just another function called setAlignment. So this is a one-to-many mappings, although the sequence only contains one method in the new API. So this is simple, one-to-many. The other opposite, the harder case is many-to-many mappings. Many-to-many mappings is that a sequence of invocation to the old API is mapped to a sequence of invocation to the new API. In this case, this is a method to create a button and add it to a panel. In the swing API, you create a button and call the panel to add it to the panel. And in the new API, you just need to call the constructor and pass a parent panel as an argument to that. So yeah, this is a many-to-many mapping, although the target is also a sequence of only one statement. So why is it hard? It looks like the same as the one-to-many mappings, isn't it? Well, it's not. The actual challenge here is that the same sequence of API invocations may have many different forms in different client programs. So what we want is just simply, whenever I see this sequence of invocation, we substitute to this one. However, in practical, they're not exactly what you think. For example, in this case, they may not even appear in the same basic block, so that they're not consecutively. In second, they may have some code inserted in between, so that your transformation has some problem because you need to figure out whether they form a match. And the second problem is where you're going to generate code. Actually, the case is not very trivial. So first one, you need to create only in the first branch. For the second one, you need to reorder the statements in a mysterious way. For example, you say why the fourth line come to the second line here. And as a result, if a API developer wants to specify this relationship, he needs to consider all possible corner cases because the API developer will not actually know what's going to happen in the client program. So this is very hard. And our question here is that, can we actually just ask the API developer to write a simplest situation and have our language to support all the transformation here automatically? Yes. And this is our insight. Our insight is normalization. So our insight here is that different forms API invocations, as presented in the last slide, can be semantically equivalently transnormalized so that the transformation is very obvious to us. What does it mean? So this is what we want. We want to, whenever we see the button creation with two methods, we want to transform into one method creation, one constructor call. So we have the first snippet. We can do a semantic equivalent transformation to push the method into the two branches, so that we can say the matching here is very obvious because it appears consecutively. For the second case, we can reorder the statements in some manner so that they will appear consecutively. And after this, the transformation is very obvious to us because they exactly match what we want. So our solution is the parallel language. So with parallel language, developers only need to specify a mapping relation between old and new APIs with only consider the consecutive cases, the simplest case. And our language will automatically identify and transform different forms of invocations in practical. So for example, we'll automatically identify there is a match here. That is what we want to transform. And we'll do a normalization so that they will appear as what we want. And we will perform the transformation. Yeah, that's all. So we just want to relieve the burden of the API developer to write the rules. So in the next several slides, I'm going to walk through the language details about what the design, how it works. So this is the syntax of paddle. The paddle looks like patch rules. So what we want to do is to transform a button to button creation. The rule looks like this. What we want to do, the first part is meta variable declaration. The meta variable declaration is to ensure that our match is not by text match, but by type match. We're matching against some objects in the code rather than some text. So here the B equals from J button to button, meaning the meta variable B in the rule is going to match an object of type B or type J button in the old program and will transform it into an object of type button in the SWT API. The parent is similar. And then we write the rules for what the source pattern looks like, what's the pattern in the old program should look like. And a plus specify what's a new method should look like. So yeah, this is just one rule to specify this transformation. And when we have this rule, let's just see how we can transform this running example. Just want to do the transformation. And this example looks like this. So the first programmer will create a button. It's a program snippet using Swing Java API. He will first create a button and set alignment to it and print the alignment number. And depending on some branch, you will either add it to a component panel or just switch to the default, add a default button to a default panel. How can we transform this with our rule? I just highlighted here that these are two statements are going to be transformed, and I'll explain how this match will be generated. So our transformation pipeline contains 5 stages. So our input is an old client program using old APIs and a set of transformation rules written by developers. The transformation process contains 5 stages. The first is pre-process, match, guided normalization, adaptation, and post-process. And the output is then a new client program using a new API so that you can directly plug into the new API to enjoy all the benefits. Well, the first part is pre-processing. Pre-processing is to transform the client program into a 3-address form so that we can match against the rules because all the rules specified in a primitive format. For example, here, in the old client program, what I highlight here is that there are a sequence of invocations here. And we want to transform into a 3-address style. What we do is to generate a new name, gen1, to split into 2 method calls. Yeah, this is pre-processing. And the second is matching. When we have a 3-address code, we just want to match the client code to figure out what's the code to be transformed. And still, given this code, we'll find first match because we can see there's a binding between the meta variable B and J button because the type match and parent to gen1 here. And for the second, although the button and default button does not have the same name, they're aliases, so they can still form a match to our rule. So this indicates our matching is done in a control flow graph fever rather than text match or syntactic match. So when we get this match, then the next thing is to how to normalize it so that it will appear consecutively, because you can see they appear in different blocks that does not appear consecutively and it has different names. And this is our key part, our key insight here is the guided normalization. We want to perform some semantic equivalent transformation on the client program so that the match statement will appear consecutively in the new after transformation. It contains 3 steps. The first, guided shift, deal with a different block. Guided rename, to make sure the alias will have same name after transformation. And guided reorder, to make sure they appear consecutively. So in order to ensure that the normalization process is semantic preserving, we need to do a dependent analysis beforehand so that we'll not break all the dependencies, make the code messy. Yeah, the first part of guided normalization is guided shift. You see, the first statement and the 2 red statement and 2 blue statements appear in different basic blocks because there are if statements inside. What we do is just to move into different branches. And particularly, the second statement is dependent on the first one so that it will be moved together with the first statement. While the previous statement has no dependency to the first 2, so we'll just leave it there to ensure that the program style is retained. I don't have a remark here because in this case, we can transform because B has no dependency to the 2 statements we are going to move into. So if there are dependencies to violate the normalization process, we'll report to the user. So because this is something we cannot automatically handle to ensure that we'll not make silent errors to the user. Okay, now they appear in the same basic block. What's the next problem? Next problem is that the names are still not the same because there are the default button and button still have the same don't have the same name. So the second part is to guide rename. The guided rename to rename aliases to give aliases to a new name to make sure the variables match to the same meta variable has the same name. So the first group is fine, already have a unified name. The second group, no. So we'll generate a new name on the for the first statement and also generate a new name for the last one. So they will have the same name. Yep. And now the last thing is to do guided reorder. We want to reorder the same basic block so that we appear consecutively to exactly match our rules. Yep. What we do here is to reorder statements by solving the dependency relations, a constraint of dependencies, so while ensuring that they can appear in the same basic appear consecutively. Also, a remark here: it might not exist a solution to perform to perform this swap, so that a warning may be generated. But as we will show later, in practice, the warning number is very small, so means like the user will only handle a small fraction of the warnings code to do themselves. Yeah, so after guided normalization, it's very apparent for us to do transformation, and then it's just to do substitution. So here is just to transform a program based on a rule. It's very obvious. It's basically just a name substitution on the code. And then a post-process, because we do the thread address, and we just don't want to let the thread address to the user to bother about further development. So we recover the process by inlining 10 variables. The Gen 1 and Gen 2 here will be inline, and this is the result, transform and use the SW API, and it's fine to users. Particularly, I want to mention the properties of paddle here. So first thing is that the guided normalization will transform programs semantic equivalently, because all the transformation algorithm can be decomposed with a sequence of semantic preserving primitives that are using compiler optimizations, so that we can totally ensure that the normalization process will not alter semantics, and only the last step of adaptation is based on the rules provided by the API developers. The second thing that we'll match and transform all the statements in one pass. So we'll not have a problem like we normalize A and then we normalize B, A is not normalized. We'll not have this problem. We're just doing it in one pass and everything is done in one pass. And proof in paper, algorithm paper. If you're interested, you can just take a look. Okay, I just showed some evaluation what we did to see whether our language is practical to capture many existing cases and whether there are many warnings or things we cannot solve. The first question is like, is it easy to use? Like, is guided normalization important in reality? And how many warnings will be generated in real cases for normalization purpose? And what's the loss? How many cannot be expressed by our approach? So we evaluate on 3 real-world cases: JDoom to Doom 4J, Google Calendar to version 2 to version 3, and Swing to SWT. We evaluate on 9 open source projects with APIs, and we search from searchcode.com by searching the API methods, and totally can thousands of lines code, and it's big. Yeah, the first question is like, is the transformation language easy to use? We don't do a formal user study, but our experience ourselves feels pretty easy because we can capture 204 API changes with 236 rules. And 90% of the rule has no longer than 4 lines. It's basically like 2 to 1 matching 2 to 2, like that. So essentially, like, how important is guidance normalization in transforming programs between APIs? In average, 28% of transformation are many relations, and 6% of that is guidance normalization, like reorder, shifting, renaming. A third question is like, how many warnings were generated? Well, there are still some warnings because not all dependencies are just so in favor of transformation. And the third warning is across the project, while we're transforming 4,000 code that use the API, and average like 0.7%. And we guess like we're comparing to the 4,000 lines, it's much easier to adapt this 0.7% the program themselves. Last, how many cases cannot be expressed? Well, there are definitely some cases cannot be expressed because not every API transformation cases can be captured by matching rules, and there are 40 to 84 lines cannot be expressed in this, and they include like class level transformations. For example, want to transform one class into 2 classes, or like loop unrolling changes some loop into non-loop. So that's something we cannot do here. Yeah, so this is our conclusion. What we solve is many mapping relations, and it's very common, and it varies greatly in user code. And Paddle is practical language to solve the problem. Developers will only need to consider basic transformation rules as if they all appear consecutively. And Paddle will magically transform all the cases automatically. And the developer is happy. Yeah, thank you. Yeah, so this is a pipeline. Feel free to ask questions.
So the result of the transformation is itself supposed to be taken by the programmer as new sources to be maintained from the resulting state. Is that correct?
Exactly.
So another issue in the evaluation is these normalization steps. To what degree does it hurt the readability as considered by the original author of the program? To what degree does the programmer consider the transformed form to be less maintainable than the original?
Yeah, this is something we didn't do actually, unfortunately. Well, I cannot answer for the moment.
Well, can you just say intuitively based on your sense of things?
Intuitively, the thing that the API is not like 10 lines. One API sequence, there will be 2 or 3 lines of code, and they will appear locally. Most transformation we do is for GUI APIs. They will not cross lines, and normalization is pretty minimal to the locals. So, and our transformation algorithm will ensure that it's only normalize the part of code that are matched. So empirically, it will not hurt, but we don't do a formal evaluation.
Okay.
Yeah. Thanks.
Okay. Yeah. The empirical was what I was interested in. Can I ask one quick more question?
Sure.
Could you compare this with an adapter approach, where you build an intermediate abstraction that implements one version of the API in terms of the other version of the API?
Yeah, we used to, actually this started from the wrapper method. Like, it used to use wrapper to wrap the function, but the thing is that this is one option, but for example, because of legal issues, you cannot always wrap others' APIs in your APIs. You know, like Oracle and like Google has something about this, and they just wrap and illegal and penalty law.
Hi. So in the pattern language, how does one distinguish between like user arbitrary bindings versus like bindings that must be fixed to match the pattern?
Oh, so because we are only mapping the rules in the API, the rules are written by the API developer, but not random code. And we have the types. The types are have qualified names about like what the packages are in. So match based on types. We will not match random name by the user. Yeah.
Hi. So you showed in your example how this works for applying a single rule, but in practice you will have dozens, if not hundreds of rules. So what I really don't understand is how that works, because every single rule gives you a sort of partial transformation, and then the other ones won't match on that part of the code anymore. And when you are applying one rule, you're restructuring the code to match that rule, so you cannot restructure it to match any other rule at the same time. So how does that work?
This is exactly something I have in paper, but not presented here because it's a little bit too complex to present. What we do is we consider all the constraints at the same time globally, so the transformation only happens in one pass. So our constraint will match all the statements at the same time. And our constraints are built on all the statements at the same time. And we solve the constraint for all the matches. If there is no global solution, we report a warning to the user.
Okay, but I guess in practice that will give you lots of problems because there might well be cases where because you're looking for a global solution and not a partial solution, you might be missing potential transformations that could actually be possible, right?
This is possible in theoretical, but in practical, people will not have interleaving different metrics at the same place. So you will not have many cross reference between different methods in a very dense way. So those are GUI APIs. So they follow the pattern in our evaluation.
A similar issue, did you never have the situation where you had statement 1 and statement 2 you want to match, and statement 1 occurs in method M1 and statement 2 has been abstracted out into method M2, and then you can't see them together with this kind of syntactic matching?
Oh, this is something. So you say one statement may be matched by 2 rules?
No, you want to find statement 1 and statement 2, but statement 2 is not expressed right here. It has been abstracted out into a helper method.
Oh, this is what we will detect in the matching phase, and this will also be part of warning. We'll report a warning for these cases because it's cross-boundary and we cannot do any normalization in this case.
So basically you see here's statement 2, and we're looking for something and we can't find the statement 1 that corresponds to it.
No, we'll look for it when the program analysis, when the match phase or match is done in a control flow graph way, so we'll find a match. But because it cross boundaries of methods, we cannot transform it and report it to the user too. Because this is like advanced things only user can do and cannot be done by the machine itself.
So in the first example where you showed the desired transformation for JButton,
yep.
It made a great deal of sense. And then you showed a case in which like the second line that you wanted to transform was inside of an if.
Oh.
And in that case, you didn't have an else. So can you rewind that? Briefly?
Yeah.
Because there appeared to be a type error in the transformation, and I'm curious how you'd address that.
So do you mean the else part? Actually, that is addressed by another rule, and I didn't show it. Well, I should. Yeah, so you're talking about this one, right? And this one is actually the second one is based on another rule. There's a mapping for like if you have two statements will transform with this constructor. If you don't have a p add in the control flow, you transform another method. I didn't show the rule here because like having too many rules in the same slide maybe a little bit hard to understand. Yeah, thanks.
If I'm not mistaken, your evaluation does not include running tests or actually trying to use it in whether transformation was correct or not. And related question is the programmer who is going to write the transformation rule has to probably do some trial and error to make it right. And I wonder how much work it actually is.
Sorry,
So did you run some tests after the transformation and make sure the transformation was correct? And also,
yeah. For the XML case and the swing to SWT case we run, but for Google that one we cannot run because the API is no longer supported. The old API doesn't support it. We only compile it, so ensure the compilation is right, but we cannot run it. Yep. More questions?
All right, thank you.
Thanks.